This week we're going to learn about balancing redox reactions when we know the reactants and products, but we don't know the reduction or oxidation half reactions because they're not found on our data table. We will use some rules for balancing each half reaction in an acidic environment. We don't have to worry about the basic environment. Here are the rules. First thing we need to do is separate the two half reactions, and then once we have them separated, we have to balance all the elements other than oxygen and hydrogen. After we have the elements balanced, then we will balance oxygens using water and hydrogens using H+, because we're working in an acidic environment. Finally, we have to make the charges on both sides of the reaction equal using electrons. Then we have to multiply the half reactions to adjust for the electrons being lost equaling the electrons being gained, and then we have to combine the two equations to produce the net ionic equation, and if necessary we have to reduce by canceling species that are found on both sides of the equation. To show this, we will use this example where CrO4 2- and sulfite ion are reacting to produce CrO2 1- and the sulfate ion. We can see clearly that the CrO4 2- must be working with the CrO2 1- in its half reaction, and the SO3 2- must be changing into the SO4 2- in its half reaction. So let's separate those two half reactions. Now that we have our two half reactions separated, we need to balance elements other than oxygen and hydrogen. So let's take a quick peek. We have chromium, and there's one on the left and one on the right, so those are already balanced. And we have sulfur, one on the left and one on the right. Those are already balanced. Next, we're going to balance oxygens using water molecules. We can see that we have 4 oxygens on the left and we have 2 oxygens on the right. So we need to add some water molecules to the right-hand side of the equation to make up the difference. I need to add 2 H2Os because each water molecule has 1 oxygen. That gives me 4 oxygens on both sides. For my second half reaction, I have 3 oxygens on the left and I have 4 oxygens on the right. I need 1 more oxygen on the left, so I'm going to add 1 water to the left-hand side of the equation. Now we have to look at hydrogens. We have just added 2 times 2, which makes 4 hydrogens on the right, and I have no hydrogens on the left. I can add hydrogens on the left by adding 4H+ because I'm working in an acidic environment. Now on the other side, I have 2 hydrogens on the left and I have no hydrogens on the right, so I can add 2H+ to the right. And now my hydrogens are balanced for each half reaction. Finally, we have to look at the total charge. So we are going to add the total charge. 4+ and 2- makes 2+ in that first half reaction. On the right-hand side of the first half reaction, we have 0 for the water and 1-. How can we make those charges equal? All we can do is add electrons, and I have a 1- charge on the right and a 2+ charge on the left. I need to add 3 electrons to the left to balance that half reaction in terms of charge. For my second half reaction, I have a total of 2- on the left and a total of 0 on the right. Now, in order to balance that half reaction in terms of charge, I need to add 2 electrons to the right-hand side of the equation. Finally, we have to make sure that the electrons balance on both sides. We can get rid of all this work for balancing charges. We have to find the least common multiple between 2 and 3, which is 6, so I have to multiply the top equation by 2 and the bottom equation by 3. And then I have to combine the 2 equations to produce the net ionic equation. So the 2 times 3 electrons will make 6 electrons, and the 3 times 2 electrons will also make 6 electrons. So they'll cancel out. And that is our goal in step 3, to make those electrons cancel out. And now we can write our half reactions in total. So I have 2 times 4H plus, which makes 8H plus from that top reaction, plus 2 CrO4 2 minus. And from the bottom reaction, I have 3 times 1 water, so I have 3H2O, and I have 3SO3 2 minus. Moving to the other side, I have 2 times 1 CrO2 1 minus, so I have 2 CrO2 1 minus, and I have 2 times 2 waters, which makes 4H2O. From the bottom half reaction, I have 3SO4 2 minus, and I have 6H plus. Now, the last step is to reduce the equation. If I have 8H plus on the right and I have 6H plus on the left, I can completely get rid of the 6H plus, and I can replace the 8H plus with 2. And I can do the same thing with water. I have 3 waters on the left and I have 4 on the right. I can completely get rid of the 3 waters on the left, and I can replace the 4 with 1. Now we should rewrite the equation to make it look pretty. And we're finished.